Hello, this is Mr. Henry, and this is the Module 4 practice test. This unit was talking mostly about solving equations, one-step, two-step, multi-step, variables on both sides, and then a little bit towards the end of slope and intercept and graphing of lines. There were some proportions in there, proportional relationships. So, let's see what we got. Number 1 says the town of Snowsville temperature dropped by 47 degrees. The equation x minus 47 equals negative 18 can be used to find the temperature it was before the drop. What was the temperature before it dropped? Okay, so it literally says we can use this equation right here. Let me see if I can highlight it or something. We can use that equation to find the temperature before the drop. Then it says, hey, what was the temperature before the drop? So let's just solve the equation. So we solve the equation. To get the variable by itself, we got to get rid of the minus 47. So we add 47 to both sides. And x equals negative 18 plus 47. Too late to be doing the work, math in my head. 18 negative plus 47 equals 29. So it was 29 degrees before it dropped. Some of these other distractors would be like if you subtracted 47. I assume negative 18 minus 47 is negative 65. This is the positive of that. If you just completely forget all about your negatives, you'd get positive 65. And I have no clue where 0 comes from. That's just the third distractor. Number 2. Hank won a bet and tripled the number of oranges he owns, plus 8 more. He now has 41 oranges. The equation, that guy right there, can be solved to find the number of oranges that Hank started with. How many oranges did he start with? So that again is, hey, here's an equation to give you the exact thing you need. What is that? It wants us to solve the equation. So we're going to take 3x plus 8 equals 41, and we solve. This is a two-step equation. You always get rid of the thing attached to the variable last. So we're going to get rid of this plus 8 first by subtracting 8 on each side. So 3x equals 41 minus 8 is 35. No, 33. And then we have 3x equals 33. So to get rid of this multiply by 3, we divide by 3 on both sides. Again, our goal is to get the variable by itself. And 33 divided by 3 is 11. I'm just checking to see other distractors. I don't know. I'm not sure. I don't even know where these other numbers came from off the top of my head, but that's how you would solve the equation. Number 3. What is the solution to the following equation? Well, there's not even a word problem there. That's just do the math. All right. I'm going to write it bigger over here so I have space. So 5 times w plus 2 equals 5w plus 2. All right, so we got parentheses here, so we're going to start by distributing. So 5 times w is 5w, and 5 times 2 is 10. All right, well, I see that there's variables on both sides. I've got a 5w here and a 5w there. So I'm going to get rid of the variable on the right. So I'm going to subtract this 5w. And on both sides, and this one also cancels out. They both cancel on both sides. So what you're left with is 10 equals 2. So I don't have a variable left, so there's no way it can be this one or this one. I don't even have a w. There can't be w equals 0 if there's no w's, and can't be w equals 6. This, by the way, w equals 0, is probably the number one missed answer. A lot of people get this far and then they don't know what to do. They just go, oh, it must be 0. No, it's not 0. If it was 0, you'd have w equals 0. Well, that doesn't exist. There's no w's left. So now we're down to these two special solutions. These two special solutions will always happen if your variable cancels out, like this. I have no variable left, so now you got to figure out which one is the proper one. Is it all real numbers or no solution? And the way that we figure this out is you look to see, is the statement that we have here true? Does 10 equal 2? If it's true, that means that equation will always be true. If it's false, that means that equation will never be true. This, 10 equals 2, is not true. This has no solution. There is no number I could plug in for w to make this side equal the right side. They will always be different no matter what you tried. If you tried to pick some number up top here, put in 5 for w, or 3, or 1, or 0. Put in 0 for w. If you do the math, you are not going to get the same thing on both sides. If you plug in 0 for w, you're going to get 10 equals 2, which is not true because there is no solution. Number 4. Frank is trying to solve the proportion, this beautiful proportion. What would he get as a solution? Okay, so 2x plus 7 over 3 equals 1 over 3, and the thing you do with proportions is you cross multiply them. So here I'm going to take 3 times 1, get 3. Here, when you take 3 times this stuff, you are taking 3 times that whole thing. It's not, is that a 7 or a 1? 7. It's not just 3 times the 7. You're also going to take 3 times the 2x. It's kind of like the distributive property, which is how I wrote it like this. It's 3 times this stuff. So when you multiply, you are distributing that 3 to everything inside. You're distributing this 3 to all the pieces inside. So you'd get 6x plus 21 equals 3. And now you just solve the equation. Now it's a two-step equation. We got rid of our parentheses. We don't have any like terms to combine. The thing attached to the variable is always last. So this plus 21 is first. Minus 21 on both sides. 6x equals negative 18. Divide by 6. Divide by 6. X equals negative 3. Letter A. Now, on a multiple choice test, and this could have been true for actually every single one of these problems, on a multiple choice test, there is a strategy you can use if you forgot how to solve an equation and still get the right answer. For example, this number 4 here. I'm going to erase all this junk. Let's say you don't remember how to solve that proportion. You have, there it is, 2x plus 7 over 3 equals 1/3. Or let's say maybe you solve this and you didn't get one of the 4 answers they have. Did I circle the wrong answer? It was positive 3, right? Not negative 3? I think it was positive 3. Let me undo. Oh, nope, it was negative 3. I was right. All right, back to what I was saying. Sorry. Let's say you did this problem and you didn't get one of the 4 choices. You don't just go, well, I'm going to pick the one that's closest to what I got. No, you made a mistake. You screwed up somewhere. You don't know where you made a mistake. You don't just kind of quit and just pick one of the choices. You look for another way to solve it. You look for another way to get your answer. So another way to do this is, well, the guess and check method. You know one of these 4 choices has to be an answer to this problem. And when you're talking about equations, the way you check your answer is you plug in what you think your answer is in for the variable, and you do the math to see if the 2 sides are equal. What maybe that is. So like, well, we know the top one is the correct answer. So I'm going to try here this letter number 3 here, letter B. So if I plug in 3 for x, positive 3. If I do this math, these 2 sides should be equal to each other. Let's see. 2 times 3 is 6. 6 plus 7 is 13. So I'm just simplifying. I just multiplied 2 times 3 to get 6. I took 6 plus 7 to get 13. And if I cross multiply here, if I look at it, if I divide 13 divided by 3, I'm not going to get 0.333. This 1/3, if I divide it, is this as a decimal. 13 divided by 3 is 4.333333333. It's not the same, which tells me this one is not the answer. I could have done that from the beginning of the problem. I could have just started guessing at what I thought my answer was. Okay, it's not 3. I'm going to try one more fake example, and I'll show you the real one. If you tried it in 12, plus 7 over 3 equals 1/3. I'm going to do this math here quickly. 12 times 2 is 24. 24 plus 7 is 31. And again, this is not going to work out. On the right side, 1 divided by 3 is 0.3 repeating. 31 divided by 3 is 10.3 repeating. It's not the same. It's not 12. Now, if you try the correct answer, what you should get, 2 times negative 3 plus 7 over 3 equals 1/3. So 2 times negative 3 is negative 6. Negative 6 plus 7 is 1. Check that out. Already we can see that's equal to each other. You don't even have to divide it, but if you choose to do so, you get 0.3 repeating on this side and 0.3 repeating on that side. Hence, letter A is still the answer. Okay? And that could have worked for all of these. Way back up here. Way back up here. I could have just plugged my 4 choices into this equation, and the only one that would have worked would have been 29. 29 minus 47 equals negative 18. 29 minus 47 equals negative 18. That is the only one of these choices that, when plugged into the equation, is true. Same thing in number 2, same thing in number 3, same thing with any problem where you're solving an equation. Well, I guess number 3 wouldn't have worked. You could have plugged in those two, the 0 and the negative, or the 0 and the 6, and when you plug them into the equation, you would find that none of those two work. So at least you could cross off those two as choices, and then you'd still be left with figuring out if it's C or D. But at least then you've eliminated 2 choices, and you have a much better chance of guessing the correct answer if you just had it come down to a wild guess. Number 5. To the 2 rectangles shown below are similar rectangles. What is the perimeter of rectangle A? Okay, so game plan. In order to find the perimeter of a rectangle, you're going to take and you're going to add up all 4 sides. So I need to figure out how big each side is, add these 4 sides together, and then one of those will be my answer. Okay. Now, the fact that they are similar figures, that word right there we learned means if 2 shapes are similar, they are proportional. You can set up a proportion. You can set up a proportion to compare these guys. So here I have this side is equal to this side, or x plus 4 over 2x plus 1 equals 2 over 3. And now I can cross multiply and solve this equation to figure out which is my answer. Well, I suppose let's just go do it. Cross multiply town. I'm going to take 3 times this stuff. 3 times the x is 3x. 3 times the 4 is 12. Notice I'm distributing the 3 times the x and the 3 times the 4. On the other side, when I take 2 times by this stuff, I'm going to take 2 times the 2x, which is 4x, 2 times the 1, which is 2, and now we solve. So I cross-multiplied. We have an equation, variables on both sides. So now, when we solve, I'm going to get rid of the variable on the right. I don't like the variable on the right side. I want him on the left, so I'm going to subtract 4x to both sides. He's gone. Subtract 4x, and I have negative 1x plus 12 equals 2. Okay, moving up there. Just write them again. Negative 1x plus 12 equals 2. All right, continue solving here. Well, I'm not going to get rid of this negative 1 first because he's attached to the variable. I'm going to get rid of this positive 12 first. I'm going to subtract 12 on both sides. Negative 1x equals negative 10. And then I'm going to divide by negative 1 on both sides. And x equals 10. Well, you're looking at that. And you're looking at your 4 choices. And 10 is not one of them. So what do you do? Well, you reread the problem. Make sure you didn't make any mistakes. And what you should find out is, we didn't actually answer the problem. We did not actually find the perimeter of rectangle A. We found what x is. This 10 is not how big this side is. It's not how big that side is. This x is literally just this x right there and this x right there. So if I plug in 10 there, that makes this side equal to 10 plus 4 is 14. That makes this side equal to 2 times 10 plus 1. 2 times 10 is 20, plus 1 is 21. And if you add these together, you get 35. That is how that distractor came about. He's incredibly wrong, though, because you don't just add these two sides. The perimeter is not just this side and this side. It's all 4 sides. So if this is 14, that's 14. If this is 21, that's 21. You add up all 4 sides, and you get an answer of 70. The perimeter of rectangle A is 70. And that's how we got our answer. We set up a proportion because we knew they were similar. We cross-multiplied and solved, and the answer we got was just x equals 10. Not the perimeter, not the area, not even the length of the side. X is 10. So when we plugged in 10 for x, now we can find the length of each side and then go through and find the rest of the perimeter. Number 6. Dr. Miller, a dentist, can clean all 32 teeth in a mouth in, not is, in 22 minutes. If this remains constant, oh, I love that word, how long would it take to clean 200 teeth? Well, the fact that it remains constant means that the slope is the same. It's a constant rate. If we're talking about constant rates, which we're not really talking about functions here, but we sort of are. Constant means it's linear. It means it's proportional. And that's the one that matters to us. This problem can be solved using a proportion. This is a proportional relationship. It says they can, Dr. Miller can clean 32 teeth in 22 minutes. Notice I've got two numbers with 2 different units. Teeth, teeth, minutes, minutes. How long would it take him to clean 200 teeth? Well, if you set up your proportion properly with the labels matching up on top and on the bottom, you know this 200 teeth has to go on the top because that's where the teeth go. This is minutes. And the question is, well, how many minutes? I don't know. So we cross-multiply. We solve. So x times by 32 is 32x. 22 times by 200, I'm pretty sure is 440, but let's just double check. What was the number? 22 times by 200. 22 times 200. See? That's why you check your math, boys and girls. My number was wrong. It's 4,400, not 440. 4,400. To solve our equation, we would divide by 32 on both sides. Take u, divide 32, equals 137.5. So if you said letter D, you are wrong. Why are you wrong? That's what we got when we cross-multiplied. Well, let me throw my units in here. This is 137. Whoa, my goodness, that was a big, huge erasing mark. That's 137.5 minutes. Look at the unit on your answer. Hours. That dude's not going to be cleaning your teeth for 137 hours. So, well, I guess you don't have 200 teeth either. But either way, the units don't match up. Our answer that we got when we cross-multiplied is in minutes. These all are in hours. So we have to convert our answer from minutes to hours. So you got to dig back into that sixth grade brain of yours. How many minutes are in an hour? 60. So if I take the number of minutes and divide by 60, that will give me how many hours? Okay, number of minutes divided by 60 equals 2.29 hours. 2.29, approximately 2.3 hours. I'd take that. Letter B is the correct answer. So, a couple trickies here. When you cross, multiply, and solve, our units were in minutes, and our answers were in hours. So we had to do a little unit conversion. Number 7, it says the graphs below show the rate at which a forest fire is spreading. The fire is currently spreading at a rate of 10 feet per minute. Which of the following graphs could be used to show this proportional relationship? Now, this phrase, proportional relationship, might seem non-important, but it's actually very important. It helps us eliminate one of our three choices here. It helps us eliminate letter B. A proportional relationship always goes through the origin. The examples I kind of gave in class, like if you're painting a wall for 0 minutes, how much are you going to paint? 0 wall. You're not going to have any wall painted. If you're typing a paper for 0 minutes, how much of your paper did you type? 0. So in a proportional relationship, it should always go through the origin. So when this forest fire started spreading at minute 0, how much area was on fire? Well, 0. Nothing. There's no fire yet. Or the fire just started. There's no fire yet. Then as the fire spreads, then you start having a larger area. So this proportional relationship is not letter B. So now we're down to either A or C. Now, how do you decide which of these is correct? Well, look back at the information. The graphs below show the rate at which the fire is spreading. The fire is currently spreading at a rate of 10 feet per minute. 10 feet in 1 minute. Which of these graphs is showing 10 feet in a minute? Well, I don't really have labels for like each individual minute. I've got like 5 minute and 10 minute and 15 and 20. So like if it spreads 10 feet in 1 minute, well, how far would it spread, say, in, well, I'm picking 5 here, in 5 minutes? How many feet would it go? If you don't know the answer off the top of your head, plug the missing number into the variable, cross, multiply, and solve. It's a proportion. That side's 50. That side's 1x, which you don't really need that 1. It's a ghost 1. Doesn't really help us. So 50 feet. In 5 minutes, it would go 50 feet. So which one of our graphs shows that? Well, not this one. This 5 minutes is like 10 feet. No. 5 minutes, 50 feet? Yes. Answer is letter A. Letter A shows it's going 10 feet per minute. If you didn't realize this was a proportional relationship and it's supposed to go through the origin, which this is supposed to go through the origin, this one is also going 10 feet per minute. These guys have the same slope. If you look at them, the slanty's the same. So that's kind of part of the distraction, is knowing that these both have the same slope, but the proportional relationship should go through the origin. Number 8. Which of the following graphs would be the graph of the equation negative 2x plus 2y equals 10? All right. Now, most of the times when we see an equation like this, the very first thing we do is we start solving for y, and that's exactly what I'm going to do. Because if I can solve this for y, if I can turn this into slope-intercept form, then all I have to do is look at my 4 graphs here and figure out which one has the right slope and the right intercept. So let's do that. Negative 2x plus 2y equals 10. And I'm going to make this y equals. So the thing attached to the variable is the last thing I get rid of. So this minus 2x is first. So I'm going to add 2x to both sides to cancel him out. So we get 2y equals 2x plus 10. Reminder, these two guys cannot be added together. That's why they just both come down for the ride. Divide by 2 on both sides to get Mr. Y by himself. And y equals 2 divided by 2 is 1x. 10 divided by 2 is 5. So what this tells me is that my slope is 1, or 1 over 1, and my y-intercept is 5. So that allows me to do a couple things. I know the answer is not letter D. That has the wrong y-intercept. This is crossing at negative 3, or 2, or something, down here. It should be crossing up here somewhere at 5, so it is not letter D. Oh, and it's not letter A. Look at that. That is not a y-intercept of 5. That's a y-intercept of 2. So it's not that one. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Okay, so both B and C have the same correct y-intercept. So then which one has the correct slope? Slope is 1 over 1. So from there you should go, since it's positive, up 1 over 1. Up 1 over 1. Up 1 over 1. That's what a slope of 1 looks like. Up 1 over 1. Up 1 over 1. It's letter C. That's the correct answer. Letter B has a negative slope. Look, it's going downhill. In fact, it's like going down 2 over 1. Down 2. I don't know. It's not even going down 2 over 1. I don't know. It's the slope's kind of weird here. But it's definitely a negative slope. It's not up 1 over 1. Yeah, down 2 over 1 doesn't seem to work. Doesn't follow that pattern. Okay? So the answer is C. Now, maybe you forgot how to do that. How else could we figure this out? It's always good to have another strategy just in case. Another strategy would be to pick a random point on one of the lines. So let's say you thought, you just guess, you think it's one of these 4, obviously it's these 4. You pick this point. That's the point 0, 2. If you plug that in to the equation, the 0 for the x, the 2 for the y, if the math works out, that means the point is actually on this equation. So for example, negative 2 times 0 plus 2 times 2 equals 10. I'm plugging in the 0 for the x and the 2 for the y. If I do the math, this gives me 0 plus 2 equals 10. 2 equals 10. Does 2 equal 10? No. This point on the line did not work in that equation, which means this is not the right line. Boom. And you could try it again for another one. Now, be careful, because these two both had the same correct y-intercept. So if you plugged in the point 0, 5, it will work. Negative 2 times 0 plus 2 times 5 equals 10 works. This gives us 0. This gives us 10. And 10 does equal 10. So if you're not paying attention, you go, oh, yay, I found a point that worked. It's letter B. Wait. More than one point has to work. Pick another point. Pick this guy right here. That's the point 2, 0. If you pick a second point and both the points work, then you're good. One point is not good enough. So if I plug in the point 2 for x and 0 for y, does that equal 10? X value is -2, y value is 0. Negative 2 times 2 is negative 4. 2 times 0 is 0. Does that equal 10? Nope. This is not the right one. But if you picked every single point on this line from letter C, every single point would work in this equation. That's why this is the line for that equation, because every single point on this line works in this equation. It's still letter C. Number 9. Paul is picking apples from his orchard at a constant rate. He's currently picking apples at a rate of 57 apples per minute. That sounds important. 57 apples in 6 minutes. Fill the table below with values that would satisfy the scenario above. Okay. Constant rate means the slope is the same, by the way. That's your slope. So I'm just going to start filling in my table. So like this guy, if he picks apples for 0 minutes, how many apples has he picked? 0 apples. And I'm not going to just pick some random number. Like I'm not going to say like in 2 minutes, in 1 minute. I'm going to kind of use this slope as my tool. Like I know in 6 minutes he picks 57 apples. I'm going to continue with this. Like if he goes another 6 minutes, in 6 more minutes he'd pick 57 more apples. That's 114. 6 more minutes, 57 more apples. And I don't know what 114 plus 57 is. 171. And you do it again. 6 more minutes is 24. 57 more apples, 228. Now, if you needed a linear equation for this, we could come up with one. Remember, time is your x variable, apples are your y variable. You could set up the equation. It's for proportion. 57 over 6 equals. Apples picked is your y variable. Time is your x variable. And if you cross multiplied this, you would get 6y equals 57x. Divide by 6 on both sides. And I bet most of you don't remember doing this in class, and that's okay. Remember I said that this is the slope? Check this out. That is the slope of the equation. Like I said, that constant rate, the rate at which he's picking apples is the slope. I actually didn't even need to set up this proportion. It's kind of almost useless once you know that this slope is just the slope in the equation of the line. So your linear equation could be y equals 57 over 6x, where x is the amount of time and y is the number of apples. Graph the values from your table in the space provided to the right. All right, so the only kind of pain in the butt thing about this is the scale. We know that the bottom axis is going to be time. We know this axis is going to be apples. I'm going to cheat. All right, my time variable needs to go up to 24. You always start at 0. And 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 10 lines. So counting by 1s won't work. Counting by 2s only gets me to 20. I don't count by 3s because that's weird. The next best thing other than 2s is probably 5s. So I'm going to go 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's kind of still spread out more than I'd like it to be, but counting by 3s and 4s is weird, so I'm not going to do that. So I guess since 2s didn't work, 5s is the next best choice. Y-axis. I bet it's like 10 lines again. 0, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. Ooh, lucky us. So 1s is too small. 2s only gets us to 22. We don't get by 3s or 4s. 5s gets us to 55. 10s gets us to 110. 20s gets us to 220, which is really darn close. So I'm guessing the best thing to count by would be 25s. In case you don't remember, I prefer to start counting by things of like the types of money there are. Like $1 bill, $2 bill, $5 bill, $10 bill. I mean, 15s are okay, but I would then go like, well, there's no such thing as a $20 bill, but 20s is still something easy to count by. And then you got like 25s, and then I'd go 50s, then I'd go hundreds. Whoa, hundreds. Like those are the things I usually count by. I don't count by weird like 15s, or I don't count by 37s or 57s or something weird. Make it easy for yourself. Here, 25 seem to be the best option. So 0, 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275. All right. So we have our scales. And now we graph. First point, 0, 0, right here. Check. Second point, 6, 57. So 6 is a little bit past 5, and 57 is, well, just a little bit bigger than 50. He's not up to 75. He's just around there somewhere, a little bit above 50. 12 and 114. So 12 is a little bit bigger than 10. 114. It's a little bit bigger than 100. It's not quite 125. It's a little bit less than that. 18 and 171. 18 is about here. 171. Well, this is 175. What the heck did I do? I'm just looking at my graph because like 18 and 171. Oh, yeah, duh. This is 150. This is 175. I had my scale wrong in my head. So 18, 175 is here. So 171 is just a little bit less. See? Whoopsie. It's still making a straight line. I for some reason in my head I was thinking my dot should have been down here, and I was very confused on why it wasn't a straight line. And if you're doing that, you should be confused too. It should make a straight line because it's linear. 24 to 28. 24 is a little bit less than 25. 228, well, this is 200. This line would be 225, so 228 would be just a teensy bit bigger. And with some skill, I'm not going to call it luck, your dot should be in a perfectly straight line. Check that out. I was doing my dots by hand, and I got a pretty much perfectly straight line. All right? And yours should be straight as well. Make it a little bit faded so you can see the dots as well. So I was able to graph my values. Lastly, number 4, a Collins type 3 says you are going to help your friend's younger brother study for his pre-algebra test where he has to solve equations. Your task is to solve the equation below and provide a clear explanation of what and why you are doing each step. So the 3 FCAs are solve the equation with no errors, provide a clear explanation of what and why you did each step, and number 3, use and circle the vocab words equation, like terms, and solution. So the thing I'd recommend you do first is just solve the darn equation. So 5x plus 3 times 2x minus 1 equals negative 25. All right, so we've got parentheses. We're going to distribute to get rid of our parentheses. That's step number 1. So 5x plus, let's see, 3 times 2x is 6x. 3 times negative 1 is negative 3. And then we have these x's. We can combine them together. So 5x and 6x give us 11x. And now we're at a two-step equation, where one thing is being multiplied by the variable, the other is being added or subtracted. So you get rid of the adding or subtracting first. It will not attach the variable. So we're going to add 3 first. 11x equals Negative 25 plus 3 is negative 22. And then finally we divide by 11 on both sides, and x equals negative 2. Answer. So now, what did we do in each step, and why did we do it? Well, in the first step here, we distributed. And we distributed because we wanted to get rid of the parentheses. That was the whole point of distributing. So distributing, or distributed, to get rid of parentheses. And then our second step. What did we do from here to here? Well, we combined like terms. We combined the 5x and the 6x to make it 11x. We combine like terms. And the reason why we do that is it's just to simplify the problem. So we only have one variable to deal with instead of two. To combine like terms to simplify the problem. Step 3, now we're in the solving phase. So now when we added 3 to both sides, we did that to cancel out this piece. So here, add 3 to both sides. And the reason why we did that is to get the variable by itself, to isolate the variable. Get the variable by itself, which is actually the same reason why in the last step we divided by 11. We divided by 11 to cancel these out. Last step, divide by 11 to, again, get the variable by itself. Isolate the variable. Get the variable by itself. And the last thing I would say is my solution is negative 2. Now, it's only right now that I'm realizing I didn't bother to check to see what the vocab words I had to use were. So I might have to do some rewriting here. So let's see. Solve the equation, no errors, check-a-rooney. Provide a clear explanation of what you did and why you did it. Absolutely. Use and circle the vocab words equation, like terms, and solution. Well, I know I actually use some of these. Like terms, right here. Circle it. Use and circle. Like terms. Yes. Solution, down here. My solution is negative 2. Use and circle. Check. Equation. Did I use the word equation? No, but I could do a small little rewrite to do that. So my solution to the equation is negative 2. Boom. Use the word equation. Love it. You could also say I distributed in the equation. I combined like terms in the combined like terms to simplify the equation. I mean, I could have used that right here instead of problem. Added 3 to both sides of the equation to get the variable by itself. So I could have used the word equation in almost every single step because that's what this problem's about. It's about equations. All right? And that would get me full credit. I solved the problem properly. I described what I did and why I did it. And I also made sure I used and circled all 3 of my vocabulary words. I double-checked my FCAs to make sure I followed them because that's how you get graded on a Collins writing. And we are done. Thank you, folks, for sticking with us. Bye-bye.